Okay guys, so what's up? For the last video, we looked at beginning to implement our simple task scheduler, a nice cooperative task scheduler. If we want a simple, small multitasking system, this is a system that could work. We use timer 0 to handle our interrupt overflows. Timer 0 performs the context switching between the tasks. We have our masters function here that allows system to support up to 3 tasks. We could increase this number as our number of tasks increase. This type of structure is good when, we need tasks to be executed in a sort of round-robin fashion. Where each task can perform a specific action, like reading sensor data. We want to control some actuators, you want to process some inputs, you want to do things like update displays and stuff like that. Each task will get a fair share of processing time. But the thing is, in a system like this, as we demonstrated in the last video, we run into some problems because if one task takes too long, then the other task can't execute at a specific time. So before we improve the system further, what I wanted to do is just take some time to improve the code structure a bit, make it more effective. Okay, so let's look at some changes we made to the code. What I did is I switched using a sort of function pointer to the task, iterate through the array in the timer interrupt. So we don't have to have this case structure and makes it easier to define tasks and stuff like that. I also reduce amount of time the function takes to return. If the task takes too long, the whole timer in the system will get thrown off. So basically we have each task stored in our array of function pointers. And when we have our interrupt routine, the interrupt routine will call the current task and it will increment our task index, wrapping back to 0 when it reaches the end of the array. It's not really a full preemptive type multitasking system, but it's still a simple task scheduler at this point. We're not dealing with things like modification of shared resources and things like that. We should take into account when designing a system like this. But at this point, if we look at the camera, the function runs. In the camera, you can still see the slight movement between them, but for embedded system application, like say reading a sensor and then you're updating a display and you want to use this type of cooperative structure to achieve that, this could work. This will achieve the task at hand. It's not very time intensive. I don't use them like a safety critical type application, but it will be good for most general type applications.